covered some important concepts in this lecture, dealing with layers, layer effects, the pen tool, even smart objects. We also talked a little bit about resolution. Quality of image depends on resolution. Now, you may have heard the phrase garbage in, garbage out. In the case of resolution, the higher the better. If you try to bring an image with 72 pixels per inch into a file that has 150 pixels per inch, you may find that the lower resolution will be soft, out of focus, just not good enough to match the quality of the 150 pixel per inch image. More pixels per inch means more data, and more data means more to play with. But all these numbers mean nothing until you understand the output choice you make or the final delivery format of your image. In general, computer monitors run from 72 pixels per inch to 96 pixels per inch. So images for the web at 100% size are delivered correctly at 72 pixels per inch. But if you want to use an image at twice its normal size, then you should have an original file that is 150 pixels per inch, since that correlates twice the resolution density. If you remember when we talked about the interface in Lesson 1, we can always find out what the current resolution of a file is by locating the dock size area located at the bottom left of the application frame. Click on that area that says dock xxm xxxm/xxm and you'll find the resolution. It'll open it up and you'll see at the bottom. Now, as a rule, you should always start out with more resolution and more image data than what you want to deliver, because it's not just resolution that you have to worry about. You also have to think about the format your image is to be delivered in. As you know from Lecture 1's Context Corner, format is very important. Now let's talk about printing and line screen. Commercial printing uses a system that involves something called a line screen. Now, because printing involves ink on paper and not necessarily photographic emulsion to show images, you need to have some concept of how this works. So if you took a magnifying glass and you held it up to a newspaper, don't look at the text, look at the image. It's not a continuous tone. It's made up of dots. That's called a halftone. And the way you figure out how big and dense these dots need to be is a function of the line screen. Now, a printed image is made up of dots of ink like these. So now you take your magnifying glass and do the same for a magazine. If you do that, stick this thing up there, there are dots that are finer, and there are more of them. If the newspaper was in black and white and the magazine's in color, you'll see a different set of patterns made up essentially of 4 colors: cyan, magenta, yellow, and black, CMYK. Take that magnifier, look at a TV, and you'll see dots as well. Or in the case of an LCD or an LED flat screen, you'll see pixels in 3 colors: red, green, and blue. Print images, for those of us that create them, will have to worry about the print screen resolution, which correlates to pixels per inch. Instead of pixels, you'll hear a printer talk about lines per inch or dots per inch. It's the same thing. The typical designer can treat them all pretty much the same. So don't be mystified by the difference in pixels to LPI to DPI. The important consideration is how you treat an image for print versus you treat one for the web. While on the web, you may want to match the resolution. With print, you need to double the resolution of the image for whatever the LPI or DPI is for the print output. Let me explain. Double the line screen. For each type of print job, there are different settings. Newspapers, and therefore newspaper ads, are usually at 133 lines per inch. That means your image should be at the very least 266. For magazines, the output screen is often 150, so you need to supply an image that works at 300 pixels per inch. You always have to ask the printer and check the specifications for the output resolution that's required. When you are working with images and pieces of images, as we did in the lecture, you need to be aware of the relative resolutions of each part. So sometimes we can get away with resizing elements that are just under the specific resolution of our basic image, but it's best to start from a higher resolution and downsample rather than upsample. Photoshop does a very, very good job of interpolating images. That is, taking something from, say, 150 pixels per inch and turning it into a 266 pixel per inch image. But when you ask it to double the resolution, you have to be careful. If you start with 300 pixels per inch and double it to 600, you're probably going to be okay. But starting with 72 and turning it over, you're making dots out of whole cloth. In other words, garbage in, garbage out. Now, resizing images. Let's talk about that. how do you change the resolution and pixel depth? Well, under the image menu, you'll find the image size command. This is a dangerously powerful and useful command. So let's take a look. Open the backyardchair.jpg from the lecture downloads. Now choose image size. Okay? The image size dialog window will let us change either the actual size of the image or the perceived size. By that I mean you can change the number of pixels in an object, essentially enlarging the document, or you can simply change the way it presents when you open it in Photoshop. So all this has to do with the resample image checkbox at the bottom of the dialog window. If you decide this image only needs to be 150, but you want it to stay at 7.7 inches, then change the resolution field to 150 and keep the resample image box checked. That's it. You'll notice that the pixel dimensions in the memory at the top change, but the document size remains the same. Let's try it the other way. Change the 150 back to 300, and this time, uncheck resample image. Notice that as soon as you uncheck resample image, the pixel dimension area loses its input fields. Now change the 300 to 150 and see what happens. The document size changes, but the actual pixel size of the file remains the same. It's all about that resample image checkbox. Combine this knowledge with what a client or commercial printer tells you about the image output that they need for the project, and you've got a winning combination.
Did you like this video? Then subscribe today to stay up to date on our channel or follow us on Google+, Twitter, and Facebook. Visit sessions.edu for more info on classes and admissions. Also, don't forget to check out the links to free downloadable content in the description. Thanks for watching.